Okay. Now, previously, we factored this expression, we factor this expression using special products. Okay, well, here are the special products, and we're going to be able to apply the special product to factor this thing. Now, I realize that I used a notation, function notation that we haven't talked about, so I'm just going to call this, there's the expression, I'm going to factor, okay? In pre-calculus class, we would give that a function name. And you see that when you get to pre-calculus. Okay, so x squared plus 4x plus 4 is what? Well, a equals x and b equals 2. That works. Again, doing a lot of these problems, you learn to spot this pattern, and it saves you a lot of trouble. Okay, because it's worth it. Perfect squares come up a lot, and they have a lot of significance. And for calculus, not to jump off of there. Okay, so what you get if you apply the special product to this, the numerator, you get x plus 2 squared. Now, x squared minus 4 is a squared minus b squared. For a equal x and b equal 2. So if a is x, you got right out root equals. Okay. First of all, this does equal a squared minus b squared for a equal x and b equal 2. So you substitute x plus 2 and x minus 2. A is x, so a and x b is 2, so a plus b is x plus 2. And a minus b is x minus 2. Well, x plus 2 squared can be written as x plus 2 times x plus 2. Denominator is x plus 2 times x minus 2. This x plus 2 divides one of these x plus 2s. Okay, it doesn't matter which ones, we'll just divide this one into this. Okay, now I've written all this out. Not one. Securely, I know what's going on. There, you can now. Okay. So x plus 2 times x plus 2 over x plus 2 times x minus 2 can be written as a product of two fractions. This one times this one, because if I multiply the numerators, I get this. If I multiply the denominators, I get this. but x plus 2 over x plus 2 is 1. And 1 times what's the x plus 2 over x minus 2 is just x plus 2 over x minus 2. Now, open math leaders will probably tell you, just cancel these, just cross them out. Okay. I choose not to talk too much about cancellation because people will not learn the rules. That includes pre-calculus students. Okay. Simply will not learn the rules. And I can't take the time to keep talking about the rules for cancellation. That's something you got to know when you come into pre-calculus. Okay. Well, the rule is if you got a factor of the denominator, it's equal to a factor of the numerator, then you can cancel. Okay. But only one of these. Okay. X plus 2 to the x plus 2. You can't cancel them both, and people will. Okay. People start crossing out all the 2's. Yeah. Well, this 2 cancels this one, and this one cancels this one. There's a minus sign there. I don't know what to do with the minus sign when I cancel it out. It must be gone. Okay. I don't think the thinking is quite as fuzzy as that, but it's not clear enough to cancel with confidence. Comes down to a factor of the numerator and a factor of the denominator. Okay. Now there's a little more too. Okay, the quicker way to write this is with practice, you will get enough to do this very quickly. You'll see quickly that this is numerator is a perfect square. And I'm going to write out the factors. I don't want to write it as x plus 2 squared, because another thing people just simply will not learn correctly is the rules of exponents. Okay. Now, this is a course we're trying to get you to do that, so you don't go into pre-calculus not knowing the rules for exponents. Okay. And not knowing the rules for cancellation. I choose to write it out like this. And then, since you can separate this thing out like this, you take this factor of the denominator with this factor of the numerator. And I even hate to do this, but yeah, you can cross them, you can cancel them out. Okay, because this is a factor of the denominator and this is a factor of the numerator. A factor is something that's multiplied by the factor of the denominator is something that's multiplied by the whole rest of the denominator. And this is, okay. Factor of the numerator is something that's multiplied by the whole rest of the numerator. And this is, so we can cancel them. I prefer to see you write things out like this. But then you can say, okay, it's equivalent to canceling. So now I've got a factor of the numerator, a factor of the denominator, and it works. Anyhow, that comes out x plus 2 over x minus 2. As long as x isn't 2. If x is 2, then you just divided by 0. Because canceling is dividing this by this. And you're not allowed to divide by 0. It's undefined. Okay. Now you'll also see open math with this as in the form x plus 2 squared over x plus 2 times x minus 2. And they might cross the x plus 2 out and then cross the square out and replace it with a 1. Well, that's kind of confusing. I want you to think this for the moment rather than this, because that could get a little bit complicated. Okay. And it's easy enough to learn to do this. That makes sense? Okay. Let's try another one. You can factor the numerator and factor the denominator. One of them can be factored using a special product, the other can't. And if it's going to use a special product, since it's a trinomial, it's got to be this one here that I can't quite put without covering up stuff. So I'm just cover up a little what we did. Okay. And here it is. I think it's visible on the screen as well as on the board. So see if you can factor that. Okay, I do apologize. The numerator that I had written down here would not have factored over the real numbers, okay? I've changed it to 8x, so that's going to factor rather easily. So if you've been watching this and trying to factor x squared plus 6x plus 7, forgive me. That was a bad error on my part. Okay. So anyhow, we got x squared plus 8x plus 7 over x squared minus 14x plus 49. Okay. Now, this one, I'll write it down here. Is this a squared plus 2ab plus b squared? Well, if it is, a would have to be x, and b would have to be 49. B would have to be 7. Now, is that the case? Well, if you square this, you're going to get the 14x, and it works. Now, if I had 15x or 13x here, it wouldn't work because we're square x plus 7. Well, let's just make sure we understand that's x plus 7 times x plus 7 equals x times x plus 7 plus 7 times x plus 7 equals x squared plus 7x plus 7x plus 49, which is x squared plus 14x plus 49. Okay. It fits this pattern, and you can do this pretty much in your head if you do a bunch of them. It depends on how well your head does at doing stuff mentally. Some people are better at it than others. Even people with equal mathematical ability, they're going to vary over the way various skills balance out. Okay, so you might not have a skill that allows you to visualize that, but you can always write it out. You can jot it down in no time. Okay, and check yourself and reinforce what's going on. Okay, so the numerator is not of the form. It would have to be square root of 7. I'm not going to do that. Okay, I'm not going to mess with that. So we try to factor it another way. Well, turns out it's pretty easy to factor. It's x plus 7 times x plus 1. And if you haven't done the stuff in factor trinomials, do it. You'll understand. You can't take time now. We've been over it very thoroughly. But I don't think anybody would have any trouble with it. So it's equal to this. And then after a few steps, that's just equal to x plus 1 over x plus 7. And the steps are the same as the ones I used over here. Okay, I would write out the x plus 7 squared as x plus 7 times x plus 7. I'll do that over here. You write that x plus 7 times x plus 1 over x plus 7 times x plus 7. And one of the x plus 7s equals this x plus 7, and you're left with x plus 1 over x plus 7. And you really want to write out x not equal to -7 because you can't be dividing by 0. Okay. And that's pretty much the process of simplifying a rational expression. I'll do a little bit more. We got a little bit more time, we might as well use it. It's our last class of the week. Let me backtrack on that and check something. Say we want to multiply these two rational expressions. Rational expression is just a polynomial divided by a polynomial. Okay. So we want to multiply these. How do we multiply two fractions? Well, it should be clear that we multiply the numerators and multiply the denominators. That's how fractions are multiplied. Remember, that's the first thing pretty much that we did in this course, was being able to add and subtract fractions, multiply and divide them, because this is where we have to know those rules. Okay. Now, adding and subtracting these things is a little more complicated. Well, that comes up next week. Okay. So be sure you review the rules for adding fractions. Okay. Make sure you know how to add fractions with numbers so that you're not blown away by adding rational expressions. Okay. If you're not very good with adding and subtracting plain old numerical fractions, you're going to have a very hard time understanding. Okay. It's one of the more difficult things in intermediate algebra. Okay. And if you can do it, that's very good. Okay, anyhow. Okay, we multiply numerators and we multiply denominators. So it's very simple. We get this. Okay. Now we factor. We get x plus 5 times x plus 6 quantity squared divided by x plus 6 times x minus 6 times x squared plus 3. Okay. Now, another thing people do when they cancel is they'll cross out this x plus 6 and they'll cross out this x plus 6. And they'll just let the square float away. Okay? They think somehow the square goes away. Or maybe it just becomes a 2. Again, this means x plus 6 times x plus 6. And when you divide it by x plus 6, you're only dividing one of those by x plus 6. Okay? Well, the very first, until you really understand how the rules for exponents apply here, and you're going to need to understand that by the time you take pre-calculus. Okay. You can kind of expand this thing. And then you see that I've got an x plus 6 here. It'll divide this x plus 6. And you could even go to the step, and I'd like to see it in action. Because if you understand this, then you'll understand much more about the whole idea of cancellation. We can verify that what I have here, if I multiply it out, gives me the numerator, and it gives me the denominator because everything is still there. If I multiply these out, I've still got x plus 6 twice, just like I have here, and I've still got x plus 5. And if I multiply the denominators, I've got x plus 6 and x minus 6, there they are, and x squared plus 3. So everything is accounted for, everything is there. I've just written this so that I know I can divide this into this. That's 1 times x plus 5 times x plus 6 over x minus 6 times x squared plus 3. And I did leave myself room, but I don't really need that 1 there, do I? Because 1 times this is just this. When you multiply something by 1, that something is what you get. 1 doesn't change the quantity it's multiplied by. Okay? And then I kind of have to come up here. I'll write what I have then. That's x plus 5 times x plus 6 over x minus 6 times x squared plus 3. And then we can multiply this out using the distributive law. We're going to get x squared plus 11x plus 30 over, and we're going to be a little careful. I'm going to say we better use the distributive law here so we don't do anything careless. Okay. X minus 6 times x squared plus 3 is x times x squared plus 3 minus 6 times x squared plus 3. Numerator is going to change. The denominator is going to become x cubed plus 3x, multiplying the x by the 3, and minus 6 times x squared, and minus 6 times 3. I'll say equals, etc. The etc. is, wait a minute, we don't have any common terms. Okay, well, the etc. is just, I would write this as x cubed minus 6x squared plus 3x minus 18 in decreasing powers of x, because it's less confusing to look at when you try to do other things with expressions like this. in a later course, okay? So you do want to rearrange this to have that negative 6x squared before the 3x. It's not wrong to write it like this. It's just not a good idea to leave it like that. When you look at a polynomial, when you look at an expression like this, you want to see it in decreasing powers of x. Okay, gonna let you do one. That's just not enough time to do this, so let's try. It's not working today. See if you can factor at least some of those terms or factors. Okay, now, of course, gotta be able to factor trinomials, modic trinomials, leading coefficient 1. So if you're not having a lot of success there, make sure you review that and work it if you haven't worked it before. So we have x plus 2 times x plus 1 here. We have x plus 2 squared here. And here we have x minus 2 times x plus 1. And here we have x plus 6 times x plus 2. So what do we see? Well, the x plus 1 matches the x plus 1, and this x plus 2 matches any one of the 3 x plus 2s we have in the numerator, right? So we could write this as this, and check. We got our x minus 2, there it is. We got our x plus 1, there it is. Got our x plus 6, there it is. Got our x plus 2, there it is. And up here, we got an x plus 2, there it is. We got an x plus 1, there's our x plus 2 squared. And all this is 1. So that simply equals x plus 2 squared over x minus 2 times x plus 6, which isn't trivially simple, but it's a lot simpler than what we had up here, right? Okay, and then we can multiply out the x minus 2 times x plus 6. Although often we want to leave it in factor form like this. We get x squared plus 4x minus 12. Okay, well, went through that kind of fast, but that's the kind of thing that we get. And it just comes down to being able to factor these and match up factors. Okay, so review what you need to review if necessary. And once you've got the factoring down, this is actually pretty easy. Okay. The next one, as I've said, where you're adding and subtracting these things, that's a little bit tough. Okay. Multiplying fractions is easy. Adding and subtracting is not so easy.